Greetings everyone. I am Uday Sharma from the EEE Department of Institute of Aeronautical Engineering. Today I am going to discuss about the topic short circuit study incorporating phase shifting components. Short circuit study is an essential process in the design and operation of electrical power systems. It involves analyzing the behavior of system during fault condition, which can help prevent catastrophic failures and ensure safety and reliable operation. However, traditional short circuit studies do not take into action the effects of phase shifting components, which are becoming increasingly common in modern day power systems. This is where incorporating phase shifting components into short circuit studies becomes crucial. Let us see what are the phase shifting components. Phase shifting components are the devices that can adjust the phase angle of the voltage and current in a power system. They are typically used to control power flow and reduce congestion on transmission lines. There are several types of phase shifting components, including transformers, reactors, and phase shifting capacitors. Each type has its own unique characteristics and applications in power system. Electrical systems can experience the faults that result in short circuits, which can cause equipment damage, fire, and personal injury. A short circuit study helps to mitigate these risks. If in an electrical system short circuit occurs, there can be the fire, damage of the equipment, and due to the fire and the damage of equipment, there can be hazards to the humans or the people operating the machines. By incorporating the methods or phase shifting components, we can mitigate these risks. Fundamentals of short circuit study. A short circuit study includes improved safety, reduced downtime, improved system reliability, and compliance with regulatory requirements. Key element of a short circuit study include identifying sources of fault current, evaluating system impedance, determining protective device settings, and assembling system coordination. That is, in a short circuit study, firstly, we need to identify what would be the sources of the fault current. Then we need to evaluate the system impedance, which may be the cause of the short circuit. Then we have to determine the protective device settings. When this is to be done to protect the equipment from getting damaged from these faults or short circuits. Next, assessing the system coordination, that is, system coordination with the protective devices and internal system coordination. Short circuit study is done in various methods based on significance. A symmetrical short circuit study assumes that all three phases of the electrical system are balanced and the fault is symmetrical. The symmetrical faults are easier to analyze than asymmetrical faults, and they are used as a basis for evaluating protective devices. And symmetrical short circuit study takes into account the differences in the impedance and phase angle of the three phases. The fault is asymmetrical. Asymmetrical faults are more complex to analyze, but they are more realistic and can provide more accurate results. A transient short circuit study analyzes the behavior of the system during the first few cycles of the fault condition. It is used to assess the performance of protective devices under these conditions. Generally, any short circuit first goes through a transient state and then goes to a consistent or constant state. During the transient state, that is, during the short circuit to the stable state of the fault, the study is called as transient study. And when the load or fault is asymmetrical, the asymmetrical short circuit studies are taken into consideration. Incorporating phase shifting components in short circuit studies. Incorporating phase shifting components in short circuit studies can provide a more accurate representation of the behavior of the power system during a fault condition. This is because these components can significantly impact the flow of current and voltage in the system. Additionally, by including the phase shifting components in short circuit studies, we can identify potential issues and implement appropriate mitigation strategies before they become major problems. This can help improve the overall reliability and safety of the power system. Short circuit calculation methods. Let us see what are the calculation methods which we can use in the short circuit analysis. Hand calculation involve using equations and formulae to calculate the short circuit current. They are a useful tool for quick calculations. However, they may not provide the level of detail needed for complex systems. Mostly in the current power systems, software analysis is used. The software analysis uses specialized software to simulate the electrical system and calculate the short circuit current. And it provides more accurate and detailed results than the hand calculation method. It is particularly useful for complex systems. Field testing involves measuring the short circuit current directly in the electrical system. It is useful for verifying the accuracy of the calculations in the previous two methods. However, it can be time consuming and expensive, and it can be also one of the riskier methods comparing to the other two methods of software analysis and hand calculation methods. Short circuit study parameters. Firstly, let us see what are the parameters we need to study during the short circuit conditions. We need to study about the fault current. We need to study about the analyze about the protective device coordination. We need to see about the equipment rating, system impedance, and the time current curve. Firstly, the fault current. The maximum current that can flow through a specific point in the electrical system under fault conditions. Suppose if the switch gets open, if this is let's the switch be in the short circuit condition in the instantly, or any fault goes under, which is represented by the switch, the all the components changes, all the basic components or parameters changes, and one of them is the fault current. The fault current, what does it do means it is a specific current in the system which is high, which is maximum during the short circuit conditions. So we need to incorporate the protective devices in the system based on this fault current. Let us see what is a protective device coordination. The process of selecting and setting protective devices in the way that ensures that the device closest to the faults operates first, minimizing damage and downtime. Equipment rating. The maximum current that a piece of electrical equipment can safely withstand without damage. System impedance. The resistance and reactance of the electrical system, which affects the amount of current that can flow through the system under fault conditions. The time current curve. A graph that shows the relationship between the time it takes for a protective device to operate and the magnitude of the current flowing through the device. One of the ways of incorporating is phase shifting transformers. Phase shifting transformers are devices used to shift the phase angle of the AC voltage or current, and they are used to control the flow of power in the electrical systems. There are two main types of phase shifting transformers and are fixed and variable phase shifting. Then there are fixed and variable phase shifting transformers. Phase shifting transformers are used in both variety of applications, including load balancing, power flow control, and voltage regulation. The advantages of phase shifting transformers include increased system efficiency, improved stability, and reduced losses. Phase shifting capacitors is one of the also equipment is one of the more another equipment used in incorporating this. Phase shifting capacitors are devices used to shift the phase angle of an AC voltage or current, and they are used to control the flow of power in electrical systems. These are also of two types, variable and fixed. Variable and fixed. Phase shifting capacitors are used in AC circuits to alter the phase relationship between voltage and current. They would be storing and releasing electrical energy, which leads to a phase shift in the current. By adjusting the capacitance value, amount of phase shift can be controlled. The capacitors are connected in series with a resistor and an AC voltage source. Forming a RC circuit, the RC circuit produces voltage across the resistor that is out of phase with the voltage across the capacitor. This voltage can be used to drive other circuit elements with the desired phase relationship. What is the benefit of incorporating phase shifting components in short circuit studies? Despite the challenges, incorporating phase shifting components in short circuit studies can provide significant benefits. These include improved accuracy in predicting the behavior of the power system during a fault condition, better identification of potential issues, and more effective mitigation strategies. Ultimately, incorporating phase shifting components in short circuit studies can help ensure the safe and reliable operation of modern power systems, which are becoming increasingly complex and interconnected. Incorporating phase shifting components in short circuit studies is essential for ensuring the safe and reliable operation of modern power systems. While they are challenging involved in accurately modeling these components, the benefits are significant and can be catastrophic failures and be prevented from the catastrophic failures. As power systems continue, evolve, and become more complex, it is important for engineers to stay up to date with the latest technologies and methodologies for the short circuit studies, including incorporating phase shifting components. Thank you. This is Ida Sharma signing off.